Welcome back everybody to my channel. Hi, I'm Lisbo the Blade, your personal mining guru, and today we again have something really special to show you, to explain you, and to teach you. And also I'm gonna reveal you something that in my opinion it's supposed to be in the game, like I think it is, but for that we need to first prove, and the proof is to find rocks to be 100% sure that this is actually true and exists in the game. Because CIG was talking about that they don't want to reveal anything to players now, that's why you cannot take, any more data from the game. So we need to find out on our own, right? And this could be one of these things. So let's show you what is new. First, we have new materials in game, and because we cannot pull any more data from the game, we need to find out on our own what is densities of these materials, because again these densities play the biggest role in mining. So what you see here is my mining data chart for densities that I made, and how I actually calculate and figure out these densities is that when you're mining and when you have the data from the rock on your right side, on your mining UI, you're gonna see that it says mass and it also says SCU. So that's a, like volume of the rock, how much you're gonna get out. So to be able to calculate that exactly, how much is that for each material, you need to first dissect the rock and you need to get 100% pure sample of that material, and then you just divide the mass with SCU. And then you get these numbers, what you see here in this mining data chart for each material. And these numbers actually vary if you have a little bit bigger piece, 100% pure piece, or a little bit smaller. It doesn't give exactly all the same numbers. And these decimal numbers are actually going more, right? But I put it on maximum 6 numbers, so we don't have to write more because it's not important, right? Even after the second or third decimal number, it's not important anymore, right? But I just wanna, put it here as an example, what I did, what my numbers are. You can see here also that we have these all materials divided by tiers, and we have from tier 0 to tier 4, and basically what this tier 0 is, it's an old continuum tier or Q tier, right? But now we have 3 materials here which are going in tier 0, and this is continuum, Stilleron, and Recite or Recite, how you want to pronounce it. We don't know exactly, or I don't know exactly how it's pronounced. So first 3 tiers are tier 0, 1 and 2. It's primary materials, right? So this is materials which you want to collect and sell, right? And then tier 3 is a secondary material which is always present, and this material is actually very valuable, but not in money, but in his density. So if the lower densities of that material, you're gonna get more ore for your tier 0, 1 and 2. And tier 4 has also this role, but tier 4 it's only inert materials, or if you want to call it dirt, like soil, right? So it's totally not valuable, you cannot get any money for that, but you have it in basically every rock. And here you can see also explanation. So tier 0 is the most rare and the most valuable materials. Then tier 1 is the common and high valuable material. The tier 2 is also the most common but middle valuable materials. And tier 3 is also the most common but low valuable materials. And on the end it's tier 4, which is actually this inert material or dirt, and has no value at all. You cannot sell it for any type of money, right? And but it's also played a very big role in mining. And here on the right you see we have like type of rocks and combinations of these tiers, what you can get inside the rock. So the most common one is where you get tier 1 material, tier 3 and tier 4, or tier 2 and tier 3 and tier 4, right? So this is when you have, for example, baxellite, and then iron, and then inert. Or in the other option where you have tier 2 first is, for example, boras, and then copper, and then again inert, right? So it's a little bit less valuable material. And this on the full right, you have just tier 3 and tier 4. So now also in clusters you can find these materials which are the low valuable materials just connected with inert, right? So this material is gonna probably have also big role in the future, but now for the money, because we're only mining for the money, not for, you know, crafting and building, they don't have any value, right? But tier 3 and tier 4 has the biggest value because of densities, right? So just remember that, I'm gonna explain that. And now here on the bottom, we have these rocks which are, you know, less common to find. And normally in this we can include continuum, right? So you have tier 0 as a continuum, and then tier 3 and then tier 4 again. And then you have these combinations where you have 4 materials. So you can have quantanium and bauxite, and then, you know, iron and inert, or you can have bauxite, terranite, iron and inert, or you can have bauxite, boras, iron and inert, right? So this is some combinations which are common to find, but they're more rare, right? So you cannot find it, you know, constantly over and over and over again. So this was just, in short, you know, what you can get and what these tiers means. But now I explain you these all new densities, especially new ones and new materials. With Pyro 4.0, we get 5 new materials, which 2 of them are tier 0, which is Recite or Recite and Steeleron, and we have 3 tier 3 materials, which are silicon, tin, and rough ice. So why all these materials are now much more important than you think? And the answer on that is because of densities. And you can see here in this chart that tin and steeleron are around the middle, and all other silicon, recite, and rough ice are almost on the top, with rough ice being the best, and it's basically the same as inert material, you know, or if you want to say dirt. So let's explain that the simplest and the fastest that I can. If you have a rock, you have 3 materials in the rock, and one of them is, for example, let's say tier 1, one is tier 3, and one is tier 4, right? The most common type of rock. So we can take as a tier 1 terranite, then we can take as a tier 3 iron, and normally tier 4 is gonna be inert, which is dirt, right? So you're gonna get certain ACU in volume out from this rock of ore, and this is gonna cost price this and this when you're gonna sell it in TDD, right? But this is not the best materials with density, and that means if you exchange one by one for the materials who has better density, that means lower density, you're gonna get more ore out for your primary material, which here in this case is tier 1, and this is now for us terranite, right? If we exchange tier 3 iron, for example quartz, density of a quartz is 1 times less. So that means this is gonna boost your tier 1 material in quantity, in ACU of ore, to get it more out. So when you need to choose which rock you're gonna mine, you're not gonna mine a rock with iron, but you're gonna mine a rock with quartz, because it's gonna give you more ore. So you're not gonna need to, you know, break 2 rocks or 3, but you're gonna break only 1, and then you're gonna, you know, deliver from 1 rock. So it's gonna be faster breaking, faster delivering, and that's more efficient, right? It's just pure logic. Same goes for tier 1 material. Also terranite is not the best material to have in the rock from tier 1 materials. What is considered density, the best is bauxite, because bauxite in comparison to terranite has almost like 1/3 better density, or if you want to say lower, than terranite. So this is again gonna boost this tier 1 material to have more ore out in quantity, in volume. But what they changed now, what is concerned tier 1 materials, is prices. So now actually Taranite is higher price than Baxalite and gold, which are all three tier 1 materials. And before, they were all three almost the same price. So now, you know, it's little bit, you know, thinking if I gonna go for Baxalite because I'm gonna get more ore, or I should take Taranite instead because it has higher value. So, you know, it's little bit, you know, questionable now. I'm gonna also show you now that in the Regolith calculator. So this is online Star Citizen tool for mining and for salvaging and to make all kinds of group activities, if you want to say it like that. And it's really nice tool to have because it can help you to understand stuff. This tool is updated, so you have also new materials. But first I'm gonna just quickly show you this, what I was explaining in this tool. And then I'm gonna show you what I was talking about on the beginning of the video, that I need to reveal you something extremely valuable and important, but for that we still need actual physical proof that this works like this and that exists. So now we're gonna directly show you how this works, you know, in practice, if you wanna say. So this is Regolith calculator. It's an online Star Citizen tool, you know, for calculating rocks, for mining, for making like group sessions, you know, for salvaging also. You can do everything, whatever you want with this tool. But what we need, it's a cluster calculator. So this is that. And here, if we press this, now we get the actual calculator for calculating how much we can get ore and how much that's gonna be money from our rock which we had in front of our ship. So the easiest to explain you that how that works is that first we're gonna put some mass, like let's say 25k mass or 25 tons or 25,000 kilograms, if you want to say it like that. So this is in tons, and we're gonna put materials like we were saying before, Taranite and iron, right? And now we're gonna put Taranite on 49%, which is like maximum what you can get from rocks. And we're gonna put iron on, let's say, so we're gonna have inert only 5%, right? Let's say like this. And now you see how much is price here. It says value and material. So this is all together. And here you can see Taranite. It says 42 SU and 326 in money, right? If you extract so much from the rock. So that's maximum what you can get from this type of rock, which is so big. So if we just change inert materials to be the highest possible, and the iron, let's say, put on 5, right? Now if we look, now it's 485k and we have 63 SU. You see how much is bigger price and how much is bigger SU what you get for Taranite. So it doesn't matter what is you getting for inert or iron. This is our primary material, it's Taranite, right? This is what we're going for in this rock. Because iron is tier 3 material and inert is tier 4. So tier 3 and tier 4 we don't want ever, you know, because it's so low value on the tier 3 that like full prospector will be maybe 20k or 15. So that's nothing. It's just not worth it to play with that, right? And inert doesn't have any value in price. So if we now, right, we're gonna put back inert like on 0 and we're gonna remove iron, which doesn't have the best density, low density. He has something in the middle, and we're gonna put something like quartz, which is one of the best now, right? And now if we put quartz on the same value like was iron before, right, and inert only 5, you see it's just maybe tiny bit, little bit over that price or the same, right? But inert is now almost nothing. we have almost 60 SEU, and this is the price. And now if we remove quartz down to have lower amount of quartz in the rock, and we put inert like this, so it's gonna be quartz 5, you see now you have over 500k price, and it's 66 SU. So this is constantly growing, how your material is getting lower density, and also inert plays big role to have more inert, because inert has the lowest density, right? Much lower than quartz. So these two are always mixing, and with that too you're gonna get better results, right? So if we now put Taranite away, because like I said before, Taranite doesn't have the best density from tier 1 materials, and the better density and the best density in tier 1 materials have Baxelite, right? So we're gonna remove Taranite, we're gonna put quartz back, let's say on full, and we're gonna put Baxelite, and now we removing quartz, putting Baxelite on 59 and quartz, so we're gonna have only 5 inert again. So you see, with this option we already have 15k more in value, and look how much SEU we have 79. So that grows over 10 SEU more in this small rock in quantity, just because we exchange Baxelite for Taranite, because Baxelite has lower density. So now again, if we push inert again up, or let's say quartz down to 5, inert more, now it's almost 600 have value, right? And it's almost, so it's not 100 SU, but it's now 92 SU of ore. This is how much Baxelite is better in comparison to Taranite because of density. So this is how this works, right? And now we're gonna show you something for Quantanium, right? I was already showing that in my density videos before, but let's just turn that off, and we're gonna put here my biggest rock that I found, my record rock, was 154.5 tons. We're gonna put 155. Let's say that like it's this. That's a huge stone, right? And we're gonna put Quantanium, and we're gonna put the tier 3 material which you're getting with Quantanium, where you can get these big stones, and this material is aluminum. That's the best what you're gonna be able to mix, to get as a mix, not that you're gonna mix, right? If we put that on the 49% and aluminum on, so it's gonna be only 5 inert. Look how much is value of that rock and how much is that SU in Quantanium. So this is like, you know, jackpot when you're finding something like that, and that's abnormal rare. And I found rocks like this, but not for with the maximum values for percentages, right? We find it with I don't know, 43% with more aluminum, you know, or with tungsten, which is the worst density, right? But I'm not showing what is the highest that you can possibly probably get on surface mining, so not in space, so that's on surface, right? And normally now if we put inert up, aluminum down on 5, now it's even more price, and if it's not much, but it's changing, right? It's 215 SU, so this is 5 million in Quantanium, but that's top of the top, right? It's just for example what I'm showing. But now what I wanna actually show you, it's something else. This Regolith calculator is updated with new materials, and now very good. Look how much is this value, so that's the maximum, right? And we now have Pyro. Pyro also have space mining or surface mining. And from all data, what we have from the old data charts for mining, we have one very interesting data for sizes of rocks. So this is factor from 2 to 9. And on Lyria and Vala in Stanton, you can find rocks which is so big. This is where I found them. And this is the biggest rocks for surface mining. And the factor of size is 8. So that means if we have 9 factor in space, that these rocks can be maximum bigger for like around 15 tons, maybe 17 tons. So around 170 tons, right? And as you see here on the left side where it's densities, the new materials have extremely low density, like this Rekite material or Steeleron, and also one more material which is tier 3 material, and that's ice. So ice have same density almost, or actually even better, that means lower than inert materials. And ice is not tier 4, it's tier 3. So that means that ice, right? Ice we can get in connection to inert. And they both have the same densities, basically. We can say the same, right? So why is that so interesting? Because on the planets or moons, you can find Rekite and Steeleron, but you cannot find ice. So ice is strictly for space mining. So that means also that we were like doing like some searching down on the planets and moons, and mostly I found some of these Rekite and Steeleron materials like on Pyro 5 moons, some of them, and also on Terminus planet, right? And also on Terminus you can find silicon, which is also great as a tier 3, and also but it doesn't have ice, right? So why is that so interesting? Because if the mining works same like in Stanton, that means that we gonna find the biggest rocks in space, which like we see here, we're going to like 170 tons. If we put ice and inert together, because you have this combination, and if we put that we can find, for example, let's say Steeleron, right? And now we're gonna put here maximum what can be size, so let's say 170 tons, and we're gonna put ice on the highest. Actually no, we're gonna put the lowest, and we're gonna put Steeleron on 49%, right? You see what it says here? How much is that? This is what I wanted to show you, all guys who are mining and who wanna get into mining. Because if this is true, and we have this option that we can find such a big stones in space, which gonna be extremely rare, right? Because this Rekite and Steeleron are the most rarest materials, but it's still option to find them. Now it's only the question if this really exists, if CIJ didn't, you know, like reduce something because they said not supposed to. We're supposed to find something like that, but we don't have physical proof yet, so we need to find them and search for them. But look how many SU is that. So this is basically 9 moles full of Steeleron material, and this is the price, right? But normally this is best of the best. And now if we put ice more up, right, and less inert, now materials it's also growing up, right? So we have 14. If we put full, it's not gonna change something, right? But the ACU is growing up because ice it's not inert, right? It's actually something, it's supposed to be something better, right? So we have much bigger quantity of ACU. It has 1707, and if you put ice down, right, on 5, now it's almost 1 times less. It's under 1000, right? So that's a big difference, right? But this is not still everything. So this, what I'm showing you, I show you with steel iron, and now I'm gonna show you with Rekite. So Rekite has much lower price than steel iron. Steel iron is almost like continuum, but Rekite has much better density than steel iron. So if we put Rekite on, and if I put on 49%, now it's 6 million more, right? And it's double amount of ACU. So this is almost 2000 ACU. So if you were want to take that, you need like 20 moles, and even that is questionable if you can take all that with 20 moles, right? So it's huge amount of ore and huge amount of money. And normally if we can put ice up, right, now it's even more here ore, but it's not changing so much, right? But why I'm putting ice here is because if we remove ice away, which has the best density, right, and we can put, let's say, quartz, you see now it's exponentially changing millions of money down, right? So we were having 20, now we're having 7 million less for Rekite. So this is why actual materials are important, which are mixed together in the rock. So the less density it has, this tier 3 material, right? This is always tier 3 material in the middle, and you normally have inert. It's always better to have higher inert, less tier 3, but with best density that you can get. And normally the tier 1 material or tier 0 or tier 2, which is going to be the primary materials, needs to also have the best possible density, and then you always pick them. This is how this works. So I hope this is much more clear, right? We can put again here so you guys can see with ice. Let's say it's back on 5. So this is what I wanted to show you, and I think this is maybe what CIG is hiding from us, because they said that we need to find out for ourselves. But now it's only the question if this is possible to find somewhere in space, because it's not possible to find on surface in such a big size, right? On surface you maybe gonna find it in maybe like till 40-50 tons maybe, right? Which is still great because it's just 2 times less, and it's still like maybe 6-7 million. It's going over the price of continuum in just 50 ton rock. But I think more likely to get these bigger sizes is gonna be in space. So this is what I want to share with you guys who are mining and who are a lot into mining. So I hope this is gonna be more clear, and I hope you're gonna find something like that. I'm gonna put links from this Reviling calculator in the description below the video, and also this chart what I made, which you are seeing through the whole video, for the rocks, for densities, you're gonna be able to take this chart, you know, as a picture from our Discord. So with all that said, I'm inviting you all to our Discord, all the players who really like mining and are wanna get into mining and learn everything. And if you wanna get help when you mining, you know, we can break rocks for you if it's needed. It's no problem for that. It's always much better to mine with a big amount of people, and then everybody have more fun and enjoy, you know, mining and just chill out and hang out. Also, if you have some questions, you can always find me on my Twitch live every day basically, which currently now I'm mining all the time in Pyro, so I can answer all your questions, or if you have some problems, it's no problem maybe to solve them directly. One more thing, what I would like to ask from you all guys who are mining, if you're mining in space in Pyro, try to write down in the comments below what is your biggest rock that you find, you know, in mass. Even if it's not some, you know, very rare material like Recite and Steeleron, just so we maybe have like some statistic, what is the biggest rock that you can find in space in Pyro. This is all from me now. I hope you guys gonna understand now much better these densities and why they're the most important thing in game. And let's hope that we all gonna find these huge and very rare stones with very rare, you know, materials, so we can make much more money and have actually much more fun breaking them, because these stones are like whole mountains, you know, so I don't know if they really exist. If you like what I'm all sharing here with all you guys who are like mining and you think that's very informative, not only please like, share and subscribe to my channel for more content. See you next time guys. Bye bye.